This is AP Precalculus. We are on topic 1.12, transformations of functions. This is a long notes, so let's dive in. There's mainly 4 different types of transformations, and this is a review from Algebra 2, so hopefully this feels familiar. Whenever you have a number being added outside the parentheses, that's always going to be vertical, meaning up or down. So if you want to add this to your notes, vertical means up or down, and translation means that you're actually going to move. So if you don't like the word translation, you can switch that out for the word move. So just move it up or down. So they have this example. If I put a -2 and it used to be that function, then it goes down to become that function. If I have a number being added on the inside, that's going to also be a translation, which again, if you don't like that word, you can switch it out for the word move. And it's going to move the opposite. It doesn't move normally. So if I say +2, you'd be like, okay, if I have that function, it's going to go right 2. And you'd be wrong. It actually goes left 2. It does the opposite. So that's the reason that there's this -h here, is because this is very key, this one is going to be opposite of what you normally think. Everything that's inside the parentheses is always opposite. This is inside the parentheses, therefore we're opposite. And it is horizontal. Horizontal, if you need to remind yourself, is the left and right direction. All right, and then what happens if those are things being added, right? Added or subtracted. What happens if you have things that are being multiplied? It depends if you're being multiplied on the outside or the inside. If you're being multiplied on the outside, that's going to be, I guess both of them are dilations, but if it's on the outside, it's a vertical dilation. That means you're doing something in this direction, which we already know, but it's nice to write it again. And generally speaking, it's going to stretch it or squish it up and down. And this is kind of key. If a is less than 0, if you have some sort of negative out front, then it's a reflection over the x-axis. So notice we have a -2. So instead of coming down, we actually go up. And then this part is down instead of up. It is reflected over the x-axis, and it was squished out by a factor of 2. So instead of coming down here to -1, it went up here to a +2. Same thing over here. When we're on the inside, we have to do the opposite of what's happening normally. You just say, oh, you just multiply it by a. No, you multiply it by 1 over b, which is the same thing as dividing by b. They put the absolute value here to say you're always going to have a positive number. The only thing that happens if it's negative is there's this reflection over the y-axis versus a reflection over the x-axis. So over here, we have g of x is equal to f of -x, and if this makes you feel like it's an even function, that is the exact definition of an even function. If I put a negative out here, then it's the definition of an odd function. And you can see that this one is just a -1 on the inside. -1 means we're just reflected over the y-axis. So this is purely a reflection in this example. All right, so all that hopefully feels comfortable. And let's move on and apply some rigor to it. So the first few questions are talking about domain and range. Let's dive in. Domain. Domain are all the possible x values, how far left and right. So domain is the left versus right. So you can see that I am allowed to go all the way to the left, and that ends at -5. So domain, I can go to -5. I can be equal to that, so let's put a bracket. And how far to the right can I go? I can go all the way until +5, because that's a solid dot or filled in point. So I can say all the way to 5, and then I can have a closed bracket. For the range, how much up and down can I go? So range is the up versus down question. So I can go all the way down to this height of -3. So I can go down to a height of -3. I am allowed to be equal to that, so I'm going to put a bracket. And then how far up am I allowed to go? All the way up to this height of 3. So all the way up to a height of +3. Cool. So that's the original function f. And then we're going to transform that. So now we're going to transform that, and we're going to call that function g. How are we going to transform it? With 3 different things. So let me label again what each of these is doing. Whenever I have a -1 in here, that means I'm shifting it, and I'll write this down. This is going right 1. You'd think, wait, isn't it minus? That should be left 1. You'd be right, except it's on the inside the parentheses. Everything that's inside is opposite. So it's going to go right 1. This one is going to go up 3. And the 2 out front is going to stretch by a factor of 2. So stretch up / down. That did not look very nice, but it's going to stretch up and down here. I can just do like that. One thing that I should note is when you move left and right, that's going to affect the left and right number. So what's going to affect the domain? Only this number is going to affect the domain. Stretching up and down and moving up 3 is going to affect the range. So this number affects the domain. These two numbers affect the range. So when I'm looking at the domain used to be -5, 5. But what do we have to do to it? We go right 1. So if I'm going right 1, then this is no longer a -5, but I add 1 to that, and it's now a -4. And we used to have a 5 here, but again, I'm going right 1. So right 1 from 5 is a 6, and we're done. We've modified the domain. The tricky part about knowing the new domain is which of these things is affecting the range, which of them is affecting the domain. This -1 is affecting the domain because it's a right movement, and domain is a left or right movement. All right, range is affected by these two numbers because those are moving it up and down. You do order of operations first, so I'm going to multiply it and then add. So I'm going to take each of these numbers and I'm going to multiply by 2 and then add 3. So -3 multiplied by 2 is -6, and then I'm going to add 3 and I get -3. Kind of back to where I started. What happens when I plug in 3? Again, multiply it by 2 and I get 6, then I add 3 and I get 9. Done and done. All right. Let's read B. We have the point 4, 2 on f of x, and that transforms to which point on the graph of g of x. Cool. Well, again, I don't care about the y-coordinate, but the original input was 4, so let's go ahead and cross off the 2. And what do I do with the 4? I guess I could just plug it in, right? So if I plug in 4 into here, let's see what happens. Oh, I think I do care. I see what it's saying. It's saying that we need to account for all of these movements. So I'm going to kind of ignore you, and I'm going to only pay attention to our analysis here. So the first thing that happens on the very inside the parentheses, that's PEMDAS, right? You do parentheses first. I'm going to go right 1. Right 1 is going to affect which of these two numbers? The x-coordinate. It's going to go right 1. So this first transforms into 5, 2 after a right 1. Next, I'm going to multiply the y-coordinate by 2, stretching in the terms of the up and down direction. That's going to multiply the y-coordinate by 2. This is now going to turn into a 5, 4. And then finally, I'm going to add 3 to the y-coordinate, not to the x-coordinate. I'm going to go up 3, and this is going to be a 5, 7. 5, 7 for my final answer. All right, and then it says find g of 0. So if g of 0 means I'm plugging 0 in for x. Again, this should be x. So this x right here is 0. I'm going to just rewrite this entire equation, but having a 0 in for the x. Let's see what happens. This is now going to be 2f of now 0 minus 1. And then that's going to be plus 3. So this is going to say f of -1 in here. So it's going to be 2 of f of -1 plus 3. So I don't know what f of -1 is until I look at the graph, right? This is the graph of f, and it's saying, hey, this is the height at -1. F of -1 just literally interprets as the y-coordinate of -1. When I go to -1, I have a height of 3. This point right here has a height of 3, so that means f of -1, whoa, didn't mean to do that, is a height of 3. Height of 3. So this is now 2 times 3 plus 3. 2 times 3 is 6. 6 plus 3 is 9. So the final answer is 9. All right. How many solutions does the equation g of x is equal to 0 have? All right. So I'm noticing this is g of x. This is g of x. If this g of x is this g of x and this g of x is 0, then 0, I'm going to plug up here and I'm going to rewrite this for the 0. So I'm going to say this is really 0 is equal to 2f of x minus 1 plus 3. So when I do that, I just need to solve here. So I need to get rid of this 3. I'm going to subtract 3 on both sides and get minus 3 is equal to 2f of this x minus 1. I'm going to divide both sides by 2, and I get negative 3 over 2 is equal to f of x minus 1. And this is where things are a little bit tricky. What this is saying is, what heights give me negative 3 halves from f? What heights of f give me a height of negative 3 halves? And I'm going to write that down because this is a really hard question for most students to analyze. Whenever I'm trying to undo this f, it's asking a question, and I'm going to write it out. So what heights, I guess here, let me be more specific about this. I'll say, what x coordinates have a height of negative 3 halves? Negative 3 halves is the question. So I'm going to come back up to the graph of f, because this is asking not about g, but f. So coming up here to f, what has a height of negative 3 halves? And negative 3 halves is about negative 1.5. So if I graph negative 1.5, let me do that with a pen. Negative 1.5 is right there. You can say that happens roughly right here, which is about, wait, am I doing this right? Is it negative 3 halves? Yeah, negative 3 halves. Oh, it doesn't ask for the exact x coordinate. It's only asking how many does it have. Well, look, it happens right here, which roughly happens right about negative 2.75. You can say that this happens at the x coordinate. X coordinate is equal to negative 2.75, which means I can come out here and say that x minus 1 happens at negative 2.75. I could add 1 to both sides. I could say x is equal to about, if I add 1, it's going to be negative 1.75. The whole point here is you don't need to know exactly what that number is. You just need to know how many times does it intersect the function. You can say this line here only intersected this black line once right there. If I had maybe this black line right here had come back down right here and had 1, 2, 3 intersections, then there would have been 3 answers. But the fact that it only intersected once means we have only 1 answer. So the question is asking how many answers, right? How many solutions? And the answer is only 1 solution. All right. E, on what intervals is g of x increasing? And that's hard. Well, we first need to look at where is f of x increasing. So f of x increasing where? So let's come back up here. So I'm going to go ahead and do my highlighter tool for increasing. What's the color that? And if I have a decreasing color, let's change that to that color. Cool. So I am increasing here, and I'm increasing here. So that's happening from negative 4 to negative 1, from negative, I pull in highlighter tool, from negative 4 to negative 1, along with 1 to 4, along with 1 to 4. Those are the 2 intervals that I'm increasing. I don't care about the y coordinates. I only care about the x coordinates when I'm talking about where I'm increasing. So similarly to what we did up here where we changed the domain, I'm going to do the same thing. Essentially, remember when we changed the domain from u to u? That's what we're doing down here. We're going to change these numbers to new numbers. And the only thing that you have to change in this whole problem is right 1. So I just need to move everything right 1. I can come down here and say, if I change everything to right 1, this is now going to be negative 3, 0. So this is g of x increasing. G of x increasing from negative 3 to 0. And if I go right 1 again, that's going to be 2 to 5. Done and done. All right, next page. This looks super similar. So in this example, we're supposed to find the domain and range of the normal function. I'm guessing this is a graph of f. It doesn't really say that, but let's go ahead and assume that this is a graph of f up here, and we have this transformation to h. So let's find the original domain. So we'll say that the for f, what is the domain and what is the range. For f, the domain, how much left and right, I can go from -5 all the way to +5. So I can go from -5 to +5. I'm allowed to be equal to them, so square brackets. My range, I can go from -3 to 3. Oh, is this the same function? -3 to 3. Oh, it is the same exact function. So it is the graph of f. Okay. But now h is defined a little bit. H is different, right? Yeah, it is different. So this is now saying, let's go ahead and do our analysis. This is now saying left 3. This is going to be down 1. Ooh, and then a negative. So this is going to be a flip over the x-axis. If it was on the inside, if the negative is in here, then it's a flip over the y-axis. So we have our analysis. How is that going to affect the domain? So the domain is the left and right numbers. So this number will affect the domain, and this will affect the height. This will affect height. So these two numbers affect the range. So again, I only have to worry about this number in terms of the domain. I used to have -5, and I'm going to go left 3, and that's going to be -8. -8. And I used to have a +5, and I'm going to go left 3, so I'm going to go to 2. So 2. All right. And how about the range? The range, it used to go from -3, but then order of operations, I'm going to multiply -3 times -2. That's going to be 6, and then go down 1. 6 minus 1 is 5. So this is 5. And then what do we have? We have 3 times -2 is -6. Down 1, -6 is -7. Oh, those are backwards though, aren't they? So here, let's go ahead and fix that. Say -7 to +5. Here we go. Cross that one off. Correct numbers, but they're in the incorrect orders. All right. A, on what intervals is the graph of h concave up? Well, we need to figure out where f is concave up. So f concave up where? So let's go ahead and figure that out. We don't have the exact inflection points, but I can see that I'm clearly concave up, concave down, concave up, concave down. And every time that you switch concavities, you have to have an inflection point. So I can see right about there's an inflection point. Right about there's an inflection point. I want to say right about there's an inflection point. They're all at the height of 1, I think. So those are the 3 inflection points. So we're concave up from -5 to -2, from -5 to -2. We'll put parentheses because you can't be actually concave up at the inflection points. We're also concave up between 0 and 3. So, and 0 to 3. Okay, we just need to change those intervals. The only thing that changes these x coordinates is this left 3. So let's apply that left 3 to both of those. So left 3 is going to change this to a -8 and a -5. Left 3 is going to be a -3 and a 0. Done and done. So that's where h concave up. H is concave up. On what intervals is h increasing? Well, to find where h is increasing, we first need to find where f is increasing. F is increasing, and then we'll find where h is increasing. And we already did that analysis, but once again, I'll highlight it. That's the eraser tool. So we're increasing there, we're increasing there. Those two intervals are -4 to -1, -4 to -1, along with 1 to 4. 1 to 4. Again, these are just a bunch of x's. The only thing that are affected by the x's is, again, this movement of left 3. So I'm going to move everything left 3. Left 3 means I'm going -7, -4, and -2, 1. Find any solutions to the equation h of x is equal to 5. So if I have an h of x and that's equal to 5, I notice I have an h of x right here. This h of x is going to be set equal to 5. So I'm going to rewrite all of that, but I'm going to put a 5 right there. Here we go. I now have a 5 is equal to negative 2 f of x plus 3 minus 1. All right, time to solve this bad boy. Let's go ahead and add 1 to both sides. So I get 6 is equal to negative 2 f of x plus 3. Let's divide both sides by negative 2. I get negative 3 is equal to f of x plus 3. This, again, is usually the hardest part for students. So this is now asking a question, which I will write down explicitly. What x coordinate has height of negative 3? So let's go ahead and find that. On a graph of f, where do I have a height of negative 3? I have a height of negative 3 right there, which has an x coordinate of negative 4. So that the answer, you say negative 4, and the answer here is negative 4. So you can say, okay, let's go ahead and undo this finding height question. So I'm going to get rid of this, and the answer over here changes from, you've used up the information of negative 3, and you say, okay, negative 4 has that position, and what's left over is this x plus 3. I know this is tricky to explain, but this is the question. So when I answer the question, this is used up, and the answer now changes to negative 4, because this is the x coordinate where the height is negative 3. And from there, I'm just going to subtract 3 on both sides, and x is equal to negative 7. Final answer, box it. Example 4. Ooh, partially completed tables, m and n, where n is that transformation. Find the missing values in the tables below, or above. This is fun. Okay, this is a puzzle. It's a puzzle, and we can just start plugging in things. So what do we want to plug in? I'm noticing if I plug in anything, I'm always going to be doubling it as my first step. So maybe if I double 1, 1 will jump out to 2, because that'll double. So let me search for u first. So let's plug in 1 for, and see what happens. So I'm going to say m of, is that going to work? N of x. Just trying to figure this out. So I'm going to do n of 1 and see what, or n of 2, because I want to figure out what n of 2 is. If you hear that noise in the background, it's my dog sleeping. So n of 2. I don't know if this is going to work, guys. This is just a puzzle. This is me thinking through it. If I do n of 2, that's going to be negative 3m of 2 times 2. Okay, that's m of 4. Do I have m of 4? I do have m of 4. Okay, that'll work. So plus 5. So that means n of 2 is equal to negative 3 m of 4. Oops. M of 4 plus 5. Okay, what do we have here? M of 4 is m of 4, and that height is 5. So this m of 4 is 5. I can come down here and say this m of 4 is 5. So this is negative 3 times 5 plus 5, which is negative 15 plus 5, which is negative 10. Okay, so n of 2 is equal to negative 10. I can come over here, n of 2 is equal to negative 10. Cool. And I'm noticing that the way that we got this, I knew that it was going to be doubling it, but that's not what ended up happening. I ended up using the fact that I had 4 m of 4. So really the doubling went backwards. So 4 went to 2. So if I want 4, I need to start with 8. Okay, let's try 8. I think, is that right? Let me just think. Oh, I need the inside to be 8, which means, I see. If the inside is 8, that means I need to start with a 4. So let's do an n of 4. N of 4, I think that will be helpful to us. Again, what might end up happening is you plug in a value in, you're like, oh, nothing worked. Like, I don't have that value. Try something else. I think n of 4 will work though. So n of 4, let's see what's going to happen here. What I'm doing here is I'm just going to rewrite all of you, but instead of this x, I'm going to write a 4. So here we go. This is going to be a negative 3 m of 2, not an x, but a 4, and then plus 5. This is going to say n of 4 is equal to negative 3m of 8 plus 5. And just like I planned, I know the value of m of 8. M of 8 is negative 12. So this m of 8 is equal to negative 12. Let's swap those out. This is going to be a negative 12. That's being multiplied by a negative 3. Then I have to add 5. And therefore, n of 4 is equal to all of that. Negative 3 times 12 is a positive 36. And 36 plus 5 is a 41. Therefore, n of 4 is 41. 41. Nice. Okay, so I have 2 of the 4 values solved. I just need to figure out these 2. Okay, so how do I go backwards then? Well, I knew that in order to find this, I'm trying to think logically. In order to find this 4, I plugged in this 4. In order to find this 2, I plugged in this 2. So what if I plug in 1? I think if I plug in 1, it will pop out as 2 because I'm going to do 2 times the 1 to get a 2 here. Let's see what happens. Nothing might happen. I have no idea. Let's see. I just have a feeling this might be nice. N of 1. Let's see what happens. It's going to be equal to, again, what I'm doing is I'm just playing. I'm plugging in 1. I'm going to see what happens. I'm plugging in 1 for this x. So this is going to be negative 3m of 2 times 1 instead of x plus 5. And n of, wait. I have an n of 1. I was going to rewrite n of 1, but n of 1 is 0. So this 0, I don't know where I wrote 1 there, but this 0 comes down here. I'm going to scribble this out and say, no, this is 0. So 0 is equal to negative 3m of 2 plus 5. Oh, that was a terrible 5. And then I can subtract 5 on both sides. So I'm going to say negative 5 is equal to negative 3m of 2. And then finally divide both sides by negative 3. And m of 2 is equal to a positive 5/3. So this is a 5/3. Nice. I should warn you guys that while doing these notes, I have not looked at the answer key at all. So if I'm wrong, I can come and redo these lessons and you can log the extra credit, but so far this is feeling right. All right, and because I'm multiplying by 2 with everything, if I plug in a 0, 0 times 2 is still 0, so I think the next value that I want to plug in is a 0, and they should somehow work out. So let's try it. Let's do an n of 0. N of 0 is equal to negative 3m of 2 times 0, and then plus 5. And I happen to know the value of n of 0 because n of 0 is negative 4. So I'm going to write over here, this is a negative 4, and then rewrite all the stuff on the right, negative 3m of 0 plus 5. Let's subtract 5 on both sides and I get a negative 9. That's going to be equal to a negative 3m of 0. Divide both sides by negative 3, and 3 is equal to m of 0. Hey, check it out. M of 0 is a positive 3. M of 0 is a positive 3. And we've solved the puzzle. I feel very smart because I didn't make a single, well, I might have made some mistakes, but like, usually what I was expecting was I was like, plug in a 5, nothing happened. Plug in an 8, nothing happened. I happened to get good information, juicy information on every single one of those. Pat on the back, Mr. Sindel. Still got it. All right. More fun with transformations. Wow. Okay, so they're defining a new f of x, and it's saying it's this function right here. It's negative 2 times quantity of x plus 3 squared times x minus 1. Kind of gross, but okay. Use the function to answer the following problems. Whoa, do you guys see the difference between example 5 and example 6? Both of them use f, but g does something different than h does. Two different interpretations. All right. Oh, and we're using our old definition of zeros. So to find zeros, we essentially set it equal to 0. And when I say set it, I mean this function, set that equal to 0, because that's really g of x. So set this equal to 0. Okay, this is how I am interpreting it. Well, yes, this does technically mean you're reflecting it over the y-axis. What I'm thinking now is algebraically, I'm just plugging in a negative x to each of these x's. These x's have all switched to negative x's. So really what I have here, I have a function that says negative 2 times not x, but negative x plus 3, quantity squared, times negative x minus 1, and that needs to be a 0. This needs to be set equal to 0, and I just need to solve this. Well, again, the very first thing I want to do is I want to divide both sides by -2, which means you're gone. And how do I make each of these things 0? This is just a nice, easy question. How do I make negative x plus 3 equal to 0? How do I make negative x minus 1 equal to 0? Well, you can subtract 3 on both sides, and you get negative x is equal to -3, divide by -1, and x is equal to 3. Or I can add 1 to both sides, negative x is equal to 1, divide by -1, and x is equal to -1. So the zeros are 3 and -1. So I'll say -1, and I'll say x is equal to -1, and x is equal to 3 for my final answer. All right, B, on what intervals is g less than 0? Oh, okay. This is a sign chart, and they set us up for it. So the very first thing that you need to do whenever you have some sort of inequality like this is to first find the zeros, which they forced us to do anyway. So thank you for doing that. And let's go ahead and make our sign chart now. So our sign chart, this is a sign chart for g, by the way. Our sign chart should have a 0 at negative, whoa, don't know what happened there, at -1, and a 0 at +3. And what we need to do now is into this function, which, why does it do that? Into this function, with the -2 still there, I'm not going to cancel that out. I need to plug in test values, and I can still use the jump trick. So I want to plug in 0. Let's see. When I plug in 0, this number right here, when I plug in 0, what's going to happen? So I'm seeing I have 0 here. It's going to be -1. So this is going to be, I'll write this up here and maybe a different, I'll have a negative. And then when I plug in anything, this is always going to be positive because it's a power of 2. So this is always going to be positive. By the way, because this one is positive, this entire thing is positive because it's power of 2. This is the number that gave us 3, which means I'm going to cross out 3 and say 3 will never change signs. It's because it's an even number here. And finally, we have this number here, which is always a negative. So if I multiply a negative times a positive times a negative, that's going to be a positive, which means down here I have a positive on this interval. Let's go ahead and do the leapfrog method. Leapfrog over here, that's going to stay the same sign, so this is still a positive. And when I leapfrog over here, this is going to change. It's going to be a negative. Okay, so on what intervals is g less than 0? Whenever I am over here. That means when I'm less than 1. So when x is less than -1. Whoa, what am I doing? I was using inequality notation. I typically use interval notation. I say between -infinity to -1. My final answer. All right, and then example 6. Example 7, how much more? Oh my gosh, this is a long lesson. All right, example 6. Let h of x equal that. Find h of 1. Okay, you just plug in 1. So if I plug in 1, what is that going to give me? I'm going to have 2f of 3 times 1. That's going to be equal to 2f of 3. What's f of 3? Does it tell us? Oh, okay, so f of 3 is this stuff up here. So I have to plug 3 into there, and then at the very end I have to double it. Okay, I can do that. So f of 3, here we go, f of 3. I'm going to do that over here, and then don't forget to double it. I have a -2 times 3 plus 3 squared times 3 minus 1. Okay, so simplifying, this is going to be -2 times 3 plus 3 is 6 squared times 3 minus 1 is 2. Oh boy, this is going to be some big numbers. So I have 36 times 2 is 72 times -2 is -144. But then I have to double it yet again because there's that 2 out there. So the final answer is going to be, this is equal to 2 times -144. So our final answer is negative 288, I think. All right. B, on what intervals is h greater than or equal to 0? So I have been prepared for this. Essentially, example 5 taught me what I was supposed to do. What I need to first do is I need to rewrite my formula and set it equal to 0 first. So I need to rewrite h. Let's see, how am I going to do that? So I'm going to write the 2 out front because I'm just rewriting u, and then f of 3x. So here comes a giant bracket, and then everywhere that there used to be an x, I'm switching it out for a 3x. So I'm rewriting u inside these giant brackets in here, and all the x's are switching to 3x's. So here we go. We have a negative 2 times, this is going to be 3x plus 3 quantity squared times, not an x, but a 3x minus 1, and that's all being multiplied by 2. And that's our function. What we need to do now is we need to set that equal to 0 to find out where the zeros are. Okay, setting that equal to 0, the first thing that I can do is I can divide everything by 2, divide everything by negative 2, and that makes my problem much easier because now I'm essentially asking where is 3x plus 3? I guess technically quantity squared is equal to 0, and where is 3x minus 1 equal to 0? Again, I can just square root this so the square goes away, and I can subtract 3, so 3x is equal to negative 3, divided by 3, and x is equal to negative 1. And then over here I can add 1 to both sides, so 3x is equal to positive 1, divided by 3, and x is equal to 1/3. So those are the zeros, but again, it's not asking where the zeros, it's asking for the intervals. That's the first step. So now what we need to do is we need to make a sign chart. So our sign chart will have zeros at negative 1, and it'll have a 0 at 1/3. And notice that this power up here is even, and that's the one that gave us u, negative 1. So negative 1 is a non-sign changer. All right, so let's plug in Mr. Sindel's favorite value. That's going to be right here, which is a value of 0. If I plug in 0, what happens? And again, I have to plug it into the original before I divide out anything. So if I plug in 0, what do we have here? I have to be careful. If I plug in 0, this is always going to be positive. This is going to be negative. I'm going to be multiplying by a negative, and I'm multiplying by a positive. All of these things are being multiplied. I kind of ignore the positive, Negative times negative is a positive, which means my final answer here is a positive. And do the sign for the leapfrog method. Non-sign still a positive. And jumping over a sign changer means I'm going to So where am I greater than or equal to 0? I'm equal to 0 there and there. I'm greater than everywhere in here and everywhere over there forever, which means the answer is that interval right there. So how do I say that? From negative infinity, ooh, that was a terrible infinity, from negative infinity all the way to 1/3, and equal to that 1/3 should be the final answer. I'm very nervous about doing this. I usually look at an answer key to check my work, but I'm just going to go for it. All right. What is the y-intercept of h? I mean, the definition of a y-intercept is where x is equal to 0. So just plug in x is equal to 0 into this equation up here and see what happens, right? Because this is the equation for h. So let's go ahead and rewrite all of that, but in the place of x, we're swapping it out for 0. So I'm going to have 2 times negative 2 times 3 times 0 plus 3 quantity squared times 3 times 0 minus 1 and brackets. All right, well, 3 times 0 is 0. 3 times 0 is 0. So this is really going to be, and I can multiply 2 times negative 2. It's going to be negative 4. So I have a negative 4 times 3 squared. So times 9 times 0 minus 1 is negative 1. So negative 1. 4 times 9 is 36. Negative times negative is positive. So the answer here should be a positive 36. All right. Then we have this one. Rational function r is given above. Use the function r to answer the following problems. Oh boy. Let k of x, we're going to transform this. Ooh. All right, well, this is the original one, and then we're going to do this. All right, I'm going to rewrite this one right now. I'm going to say this is really equal to, here, there's the -4. I rewrote the -4. Now I'm going to rewrite all of this. R of negative x over 2 is the same thing as saying rewrite all of this, but in every single one of these x's, we're swapping it out for a negative x over 2. So here's how that looks. It's going to be a fraction. Hopefully that's long enough. I have a negative x over 2 minus 3. That's the first one. And a negative x over 2 plus 1. And then I have a negative x over 2 minus 3. And finally, a negative x over 2 plus 4. All right, I literally, this is our exact function for k of x. I can ignore the middleman now. So where are the values where we have a vertical asymptote? Just a reminder, for vertical asymptote, that's where the bottom wins. So set the bottom equal to 0. A hole is where you have things that cancel off on the top and the bottom. So let's do the vertical asymptote second. Let's do the hole first. So the hole is where things cross off. Check it out. This number and this number, or this linear term, I should say, are the same, because I knew that these two were originally the same. So these two should cancel off. So let's go ahead and set that equal to 0 and see what happens. If I have negative x over 2 minus 3, if I set that equal to 0, let's see what happens. If I add 3 to both sides, I get negative x over 2 is equal to positive 3. If I multiply both sides by negative and 2 at the same time, I'm going to get x is equal to negative 6. So there's the hole. So I'll say there's a hole at x is equal to negative 6. Done. And now we're going to do the vertical asymptote. That's where the bottom is set equal to 0. I'm not using u because that was the hole. I'm using u. So set that one equal to 0. So I'm going to set, this is the vertical asymptote, by the way. Vertical asymptote is where negative x over 2 plus 4 is set equal to 0. Let's go ahead and subtract 4 on both sides. I'm going to get negative x over 2 is equal to negative 4. Let's multiply both sides by a negative and a 2, which is going to make this a positive 8. So x is going to be a positive 8. So there's going to be a vertical asymptote at x is equal to 8. Cool. B, for which values of x is this thing greater than or equal to 0? Oh my gosh. So the other thing that we need to have is the actual 0. So there's 3 things that you need to do an analysis for, right? You have holes, you have vertical asymptotes, but you also have, so we use that for the hole, we use that for the vertical asymptote. We have yet to use this last term in the top right. This term right here is going to give us what's called a 0. Let's do the 0 analysis. So to find the 0, I'm going to set negative x over 2 plus 1 is equal to 0. And let's see what happens. If I subtract 1 on both sides, I get negative x over 2 is equal to a negative 1. From there, multiply both sides by 2 and a negative, which is going to make this a positive 2. So x is equal to positive 2. So there's 3 things that I need to avoid on my sign chart. Let's go ahead and make our sign chart. So 3 things to worry about. I have, the first coordinate is a negative 6. There's a hole there. I have x equal 2, that's a 0 there, and I have a vertical asymptote right here at 8. All right, so there's the 3 things that can affect our graph. Do any of those have even powers? Let's check it out. So in the original problem, all of these had odd powers, and this one also has odd powers. So each of these should be a sign changer. Oh, wait. This should not change signs because this one is essentially canceled out. So this one, what did that give us? That gave us a negative 6. This one doesn't matter. This one doesn't matter because it's essentially crossed off. So let me go ahead and just, I'm not even going to put an X through it. It's not a sign. It's a non-sign changer technically, but it would be even more apt to just scribble it out like that. And oh, I didn't know you could do that. And just be like, no, it's gone. It wasn't there to begin with. But for the sake of just having a nice, fully explained graph, I'm just going to cross it off and say it doesn't change signs because I don't really care about it. So from here, let's go ahead and plug in a number like 0, my favorite number to plug in, and see what sign I get. So I'm plugging it into this original function because there is that negative that I'm worried about outside. So there's a negative right there, which I won't forget about. These guys are canceled out, so I'm going to ignore them. And then finally, when I plug in 0, everything here is 0. I'm going to have a positive. Everything here is 0, and I'm going to have a positive. So I'm going to have, I already said it, it's a positive right there, a positive right here. Everything here is positive. Those don't matter. The only thing that matters is a negative in this case, which means I have a negative in this interval. Time to do leapfrog method. Ready, set, doesn't change, right? Basically ignore. Leapfrog method again over here. This is going to be a positive. Leapfrog method again. This is going to be a negative. So where am I greater than or equal to 0? I'm not technically equal to 0 here. That is a hole. I have emptiness here. That's not technically equal to 0. I'm equal to 0 only at the 0 of a 2. So I am equal to 0 here. I'm not equal to 0 here. That's just a vertical asymptote at 8. So I can't touch -8. I can touch the 2 though. So I can touch the 2. I can say my answer, I can touch the 2 and I can go all the way to 8, but I can't touch the 8 because that's a vertical asymptote. So the answer here is between 2 and 8, including the 2, not including the 8. All right, another page, and okay, that is the last one. This has gone a while. You can see the time in the top left. It's very cold in this room and I'm very tired. All right, the function p is a cubic polynomial with selected groups of given in the table above. All right, and we're transforming it that way. Cool. Describe the transformations of p that lead to the function m. Oh, okay, so this is literally what I would do anyway, but it's asking me to write it out explicitly. So in here, the very first thing that happens is on the inside. When I have a +4, that is it's a move, a translation, left or right. So now that we have to describe it in words, we have to use official terminology. Instead of saying move, I have to say translate. So I'm going to say translate 4, and this is going to be +4, so it's actually going to be left 4. Translate 4 left, and then there's two other things happen because a minus sign on its own does an entire operation. The minus sign is going to do a reflect, so I'll say reflect over the x-axis. If the negative sign had been on the inside, it would have been a reflection of the y-axis. This is just going to flip the top to the bottom or the bottom to the top. And then finally, we're going to have this vertical dilate. So we're going to say vertical dilation by factor of 3. iPad? All right, I think iPad is still responding. So B, name an x value where the graph of m of x has a 0. Okay, m of x has a 0 just means that m of x is equal to 0. So this m of x is equal to 0. So I can just go ahead and rewrite this and say 0 is equal to all that negative 3p times x plus 4 stuff. That's the very fancy definition. Has a 0, makes it equal to 0. I just need to solve for you. First thing I'm going to do is divide both sides by -3, which is as if I just cross it off. So I have 0 is equal to p of x plus 4. Again, this is usually where students get uncomfortable. How do I undo that p? It's asking the question. I'm going to write down the question explicitly. What x coordinate has height of 0? Oh, don't know why I ended with that. Height of 0. And we have a height of 0 right there. So the answer, by undoing this p, the answer is 2. So we can say that 2 is the answer, and that's going to be undoing the p, leaving us with an x plus 4. Finally, I can undo this plus 4 by subtracting 4, and I can get -2, therefore is equal to x. So x equals -2, I will have a height of 0. And I think we can check that. Let me just see. if I plug in -2 into our function, -2 being plugged in here, that's going to be -2 plus 4, which is 2. P of 2 is 0, and then 0 times -3 is 0. So yeah, it all works out. All right, C, find the average rate of change. Okay, so that means we need the y-coordinate and the y-coordinate, because in general, every time you see average rate of change, you always think slope, right? Average rate of change, cross it off, you say slope. And here's how you do slope. The slope is m of 2 minus m of 0 all over 2 minus 0. We don't have m of 2, we don't have m of 0, so let's go ahead and find those. M of 2 is equal to -3. Okay, what am I doing here? I don't know what m is, so I'm going to go ahead and just rewrite all of you, but in the space where x is, I'm going to plug in a 2. So I'm rewriting all of this right now. So -3 p of 2 plus 4, and that's going to be, actually, I'm going to move down instead of right. So it's going to be equal to -3 p of 6. P of 6, hopefully you have that. Okay, p of 6 is a 7. So p of 6 is 7, so I'm going to swap that out for a 7. That's still being multiplied by a -3. Therefore, that's equal to a -21. So m of 2 is equal to a -21. Let's go ahead and fill some things in. -21 minus the next thing all over 2. Okay, time to figure out what this m of 0 is to fill in that missing spot right here. So what is m of 0? Again, I don't know, so let's go ahead and just plug it into this and see what happens. So this is going to be -3 p of 0 plus 4, which is going to be equal to -3 of p of 4. And that's going to be equal to, hopefully I have p of 4. P of 4 is 3, so I'm going to switch this out for a 3. And that's going to be a -9. So I'm going to put in a -9. Notice the double negative. Be careful of the double negative. And double negative means there's actually a plus in here. -21 plus 9 is -12. Is that right? Brain is not working as fast as it normally does. -12 over 2, which is equal to a -6. I think the final answer here is -6. By all means, please check the actual physical answer key and see if I know what I'm doing. All right, D, find the domain and range of m of x. Okay, well, first we need to find the domain and range of normal. Wait a sec. The domain, wait a sec. This is a discrete function, which means every single value in here has to be translated. Is that right? Usually what happens when we have something continuous, here, let me come back here. Back here, this was continuous. There was a line of infinite number of values. We said, hey, everything between here and here. That's why we said everything between here and here. That's called continuous. But when we turn this into a table, we have to manually say you, and you turn into who, and who. Pretty sure that's what we have to do. That's annoying, but okay. We can do that. It's essentially doing this and this over and over and over again. So here we go. I think that's the case. Let me just check. Yes, that is exactly the case, because domain and range. What can we plug in? Domain is asking, what can we plug in, right? Oh, but that's super easy to do. Okay, here's the shortcut though, because we have this formula up here, right guys? And this formula, it already said this, all of this stuff. The domain is only affected by translating left 4. The range is only affected by these things. So essentially every single one of these coordinates, yes, we have to do it, but it's so easy. 4 left. What's -2 and then 4 left, right? So here we go. The domain is going to be -2, but you go 4 left, and it's going to be -6. 0, and go 4 left, it's going to be -4. We have 2, go 4 left, you go -2. You have 4, go 4 left, you get 0. And 6, go 4 left, you get 2. Done. All right, what about the range? This might be a little bit trickier. Again, I'm taking every single value, and I'm running it through these things. This, and I'll write this down. This one affects the domain. these two affect, oh, that was a bad curly brace. These two affect the range. So I have to run them both through range. All right, we had a y coordinate of 1, then I have to do reflect over the x-axis, so this turns it into a negative. It's essentially taking this value and I'm multiplying it by -3. That's the fancy way of saying this. Multiply all these by -3. 1 times -3 is a -3. -1 times -3 is 3. 0 times -3 is 0. 3 times -3 is -9. 7 times -3 is -21. I don't know if that's even close to what I'm supposed to do, but that's what I feel like I'm supposed to do. Okay. E, for which value does m of x is equal to 3? All right, I mean, this is pretty straightforward. We've been doing this over and over again. If m of x is 3, this m of x is 3. So I'm going to rewrite all of this, but in the place of this m of x, I'm going to write 3. So I'm going to say 3 here is equal to -3p of x plus 4. And I solve. All right, so first divide both sides by -3, so -1 is equal to p of x plus 4. Again, this is usually pretty tricky for students, but maybe you've caught on by now. You can say, what x coordinate has height of -1? And there's only one, right? Because height of -1, that x coordinate is 0. 0 is the magical answer. So I'm going to come over here and say, okay, 0 is the answer. And I can now undo this p, and I'm left with an x plus 4. So I can say this is x plus 4. Finally, subtract 4 on both sides, and x is equal to a -4 for our final answer. And you can check your work too. Like, plug back in -4, and you'll get an output of 3. All right, our very last question. All right, the domain and range of a function are -6 and 9. That's the domain. That's the domain. And this is the range. Additionally, n is increasing there and decreasing there. Got it. Okay, find the domain and range. Okay, this is pretty straightforward. So let's go ahead and analyze what this is doing. Oh, straightforward, is it? There's 4 things that are happening instead of 3 or 2. That's so tricky. Ooh, this is a hard problem, guys. Okay, so whenever we have a negative x in here, that's a reflect over the y-axis. Just making sure. No, reflect over the x-axis, sorry. Nope, reflect over y-axis. I don't know what I was saying. This is a reflector of the y-axis, 100%. Final answer. If you add a 5, this is really saying +5, right? I could have just switched these two and it would have been a +5. Adding a 5 means go left 5. So this says go left 5. This 2 here means vertical stretch it by 2. So I'm just going to say stretch. This minus sign down here means it's a reflect. Oh my gosh, come on, handwriting. It's so cold in here. Reflect over the x-axis. And this 4 means it's like adding 4, right? This means go up 4. Whew. So like 5 things that are really happening. Find the domain and range of q of x. Okay, so we have to analyze which of these are affecting the range and which of them are affecting the domain. So let's go ahead and put an R or D next to all of these. Up 4, that's a y change, so that's going to be a range change. Stretch is going to be a range change. Reflect over the x-axis is a range change. Go left 5 is a domain change. And a reflect over the y-axis is a domain change. You might question, like, how is that a domain change? So if I have my x and y coordinate, if I have a number over here, and I reflect over this x-axis, so it comes over here, that changes the x coordinate, therefore it is changing the domain. All right. So I originally had a domain of -6. Let's go ahead and find the new number. So the domain now, I have to run it through these two numbers. First, make it negative. So instead of being a -6, it's now a +6. And then go left 5. So +6, but go left 5 is going to turn into a 1. And then I take 9. So 9, make it negative. That's a -9. Go left 5. That's -13. So 1 to -13. Those are backwards, so they should be in brackets. But again, that's backwards, so no, try again. It's actually from -13 to 1. Perfect. Okay, what about the range? So these three things are going to affect the range. We'll do them each in their own way. So I'm going to start with -8. -8, the very first thing I'm going to do is I'm going to multiply by -2. So multiply by -2, that's going to turn into 16. I add 4 and I get to 20. 20. Okay. Then I'm going to take 10. So 10 times -2 is -20. -20 plus 4 is -16. So -16, again in the wrong order. So it should go like that. Again, this is going to change to a -16, which it can't be equal to, and a 20, which it can be equal to. There we go. A little bit tricky. And then, oh my gosh, last question of this entire notes. We're almost there, guys. On what intervals is Q increasing and decreasing? So here's the thing. When you have a function, right, let's go ahead and just make a sketch for a sec. Let's go ahead and say I had a function that was doing this, where I'm always increasing no matter what I do. For the sake of making this easier, it's a line. If I reflect, there's two reflections, and I'm worried about if I'm increasing or decreasing after double reflections. If I reflect over the x-axis and then reflect over the y-axis, so if I reflect over the x-axis, it turns into this. So this is going to turn into this, and if I reflect over the y-axis, it's going to turn back to this. Reflecting over the x and y-axis in terms of affecting the increase and decrease doesn't do anything. So I'm thinking I can probably just ignore that. I mean, I can ignore the -1 here. I do have to account for the fact that there's a 2 there, but this negative sign and this negative sign are irrelevant. They might as well be plus signs. If both these are plus signs, it was the same thing as if they were negatives. The 2 does affect us, though. Okay, so with that analysis, my hand is shaking because it's so cold in here. Let's go ahead and find the original intervals. So it's increasing on that interval. So we'll say increasing. The original interval was from -6 to 1. So these are all x coordinates. Just as a reminder, this is an x coordinate, that's an x coordinate, x coordinate, x coordinate, x coordinate, x coordinate. Everything is an x coordinate. X coordinates are only affected by the domain. So I can ignore all of you guys. I only have to do you and you, which means multiply by negative, add 5 to each of these numbers, and we are done, I think. So let's try this. So it's increasing from -6, so it's going to be multiplied by -1, turns into a +6, and then add 5, and that's 11. So this is going to be 11. And the number is 1, but I'm going to multiply by negative, so -1. Wait, did I say add 5? This means left 5. So that's wrong. Okay, hold on. Try this again. Getting too late. It's 1:22 in the morning. Multiply by negative. That's correct. Turns into a +6. Go left 5. That turns into a 1. Done. I have a 1. Multiply by the negative. It's a -1. Go left 5. When I'm already at -1, that's a -6. That's in the incorrect order, so this is going to really turn to a -6 and a +1. Okay, the other interval that it's increasing was from 5 to 9. Let's do with 5 first. 5, turn it negative, it's -5. Go left 5, it goes to 0. So this is going to be 0. That one was a square bracket. This one is a parentheses over here. Now we have a 9. Make it negative. It's a negative 9. Go left 5. When I'm already at negative 9, it goes to negative 13. Negative 14, sorry. Negative 14. Those, again, are in the wrong order, so I'm going to do negative 14 to 0. Negative 14 is parentheses, 0 is a square bracket. So cross those out, cross those out. Cool, done. Decreasing. The decreasing interval used to be 1 to 5. So 1, I'm going to make it negative. So it's a negative 1. Go left 5, it's a negative 6 now. So it's a negative 6. That one was a square bracket. That one was also a square bracket. Last question. Here we go. 5. Make it negative. That's a negative 5. Go left 5. It's a negative 10. Negative 10. Those are in the wrong order, so cross it out and make it the right order. It's a negative 10 to a negative 6. And there's our final answers. Yes! Good job, guys. Okay. I am a good 80% sure I've done everything in these notes correctly because I haven't been looking at the key. Most of the time I make lots of mistakes and the key is like, oh, and I learn from it. I apologize. I record this all in one take, and if I made any mistakes, I will fix them with you guys later. Thanks for watching. I'll see you guys later.